My name is Jake Sullivan. My student ID is 01752941, and I have not collaborated with any other student in making this video. So today we're going to be talking about two variables and making a scatter plot for them. These two variables, as shown in the instructions, are high school graduation year and GPA. Since we don't have any data for high school graduation year, we're going to replace that with age, and that's going to be fine because as long as we use two quantitative variables, we can still make that scatter plot. So we're going to, once we do make that scatter plot, we're going to talk about its form, direction, and strength, and those are all parts of its pattern. We can also talk about its response, which variable is the response variable and which is the predictor variable. I can tell you right now that age is the predictor or explanatory variable, while GPA is the response variable, the variable of interest. So, and our response variable will lie on the y-axis, while our predictor or explanatory variable will lie on the x-axis. And we're going to come here to StatCrunch, and we'll go into graph, and we come down to scatter plot, and we'll select our x variable, which, as I was saying, is age, and we'll select our y variable, which is overall GPA, and we'll come down here and click compute. And we have a nice scatter plot here that I'm going to expand to view better. And now that we have a nice view of that, you can see, just as I was saying, overall GPA is going to lie on this y-axis, while age will be on the x-coordinate. And from this scatter plot, we can tell a couple things. For one thing, we see the direction that it travels is positive. It travels from the lower left to the upper right. And we can also see its form. Its form seems to be nearly straight. However, it does seem to have a little bit of a curve here. And I believe that's because it seems that in this younger, lower range here, around 20, you see a high variance in GPAs here, where you have quite a few people with lower GPAs and you have quite a few people with very high GPAs. While you see up here, it's much more consistent that as you grow in age, as you get older, your GPA seems to be more consistently higher. You can also see there's a couple of outliers down here where there's some students who are older but still have low GPAs. And that tells us a little bit about the strength of this scatter plot, which I would call weak to moderately strong. And I think that a strong scatter plot will usually have a very tightly clustered line, a more discernible line that you can really pick right out. While in this scatter plot here, you see it's a much larger, much more, takes up a lot of space. It's a much larger cluster. So now that we've looked at that, we can exit out of our scatter plot here, and we'll come back to our instructions, and we'll look at our next step, which is demonstrate how to run the correlation coefficient, and then once we get that number, I'll explain to you what that means. So we come here to stat, and we're going to come down to summary stats, and we'll go to correlation, and we'll click on that, and we want to select our two variables again, which were age and overall GPA. And now we have those, we're going to compute, and we see our correlation coefficient between age and overall GPA is 0.2495. And what this tells me is a couple things. Correlation coefficient tells us the direction and the strength of the linear association. This coefficient tells me specifically that it's a positive direction, which is what I was saying before. And I know that from this number here because a positive correlation coefficient will have a positive relationship on that scatter plot. It can also tell me the strength, and this one here tells me that it is rather weak because usually, well, always the correlation coefficient ranges between -1 and +1, with the strongest of those values being closest to -1 or +1, and the weakest being closest to 0. So now that we've looked at that, I'm going to exit out of here, and I'll come back to instructions again, and we're going to see that we want to make a prediction of a GPA for a 25-year-old student here, and we're going to do that on StatCrunch as well. So we're going to come in here, and we're going to go to Stat, and we'll come down here to Regression, and we'll click on Simple Linear, and we're going to select our X variable. Our X variable will be the same as before, age. That's our predictor variable. And our Y variable, which is the response variable, is our overall GPA, again, the same as before. And now we got to come down here because we want to predict Y. So we're coming down to prediction of Y, our prediction of overall GPA for our X value, a 25-year-old student. So we'll plug in 25. And now that we've got that plugged in, we can hit compute. And we got all this nice information here that I'm going to bring down, and we can look at. Here's our predicted value of X. That's or our predicted values here. And here's our X. That's our X that we plugged in, 25, our 25-year-old. And his predicted overall GPA is approximately 2.73. So what this tells us is that for a 25-year-old student, it's a good prediction that they will have an overall GPA of a 2.73 based on this relationship and this data. Now, if I click to the next page here, we're going to look at a line of best fit. This line is also sometimes called the least squares line, and this means that the sum of the squared residuals is smallest at this line. And what a residual value is the difference between a point that falls on that line and the next closest value on that same x coordinate. So it's just a good way to find that line of best fit, the line that really shows that trend in there. This is also sometimes called the regression line. And I believe that's all we have to talk about today. So thank you very much for watching my video, and I hope that you learned something, and I hope you have a nice day. Thanks.